reading this paper changed how I think about artificial intelligence.
So I think eventually once AI becomes more intelligent than us, we will be able to stop knowing how intelligent it is, and we'll have to use AI to test AI. Like the AIs will need to design a test and tell us how intelligent the other AIs are.
I mean, it's like a pro tip for using these tools.
There's all these little tricks about like adding context, adding examples, and adding like this chain of thought reasoning. There's so many things. Like we have this massive list of things, and then we have a massive database of prompts that work. There's a lot of these little tricks that make it work, kind of similar to a psychologist for AI. That kind of scared me. I think the really big limitation I saw, which they'll probably fix in GPT-5 or whatever, it wasn't actually able to think to the end. If you ask it, how long will this prompt end up being? It gets the answer wrong because it doesn't know actually how long it's going to be. Do you think it's just kind of like actually a reflection? I mean, OpenAI is not as open as we hoped, but they're more open than Google. And so maybe they just release it as it comes out, whereas Google's like, let's make sure this thing's all finished.
Today, we want to talk about this paper that was released by some researchers at Microsoft. And the title of the paper is Sparks of Artificial General Intelligence, Early Experiments with GPT-4. And in this paper, the authors go through various experiments that they ran on GPT-4. And what they were trying to do is sort of test it for intelligence. And, they define what they mean by intelligence in the paper. And I found this really interesting. Actually, like reading this paper, the bits of it I got through like changed how I think about artificial intelligence. I kind of went from being semi-skeptical, sort of like, well, it's getting better, but it's got some clear edges that just really need to be refined. And I kind of had this view that these LLMs are impressive to an extent, but maybe it's just kind of like a parlor trick. To reading this paper and seeing like all of these emergent capabilities that are coming out of this model that was not explicitly trained to do any of this stuff. And so I was thinking we don't have to go through it in order that they did in the paper, but we could go through some of these different areas that they experimented with GPT-4 and just kind of talk about them. And maybe the one that kind of makes the most sense to start with is coding.
So what I would also like to do is just make some general comments. So let's go through them, like the tools and the software engineer. But I also want to make some general comments. I didn't read the whole paper, but I skimmed some of the key results. And so I'd love to also just make some general comments on that, if that makes sense in your agenda.
Yeah, definitely. I mean, let's start there then. Like, what did you think about this? Like from what you read and what you gleaned?
Yeah, so I mean, it's obviously amazingly impressive, and I feel grateful for living in the time that we do. It's a lot of things I've been hoping for since I've been working in the AI field for the last 15 years, doing my research at MIT and starting multiple AI companies. So it's like finally we're at a spot where I've wanted to be. And so, okay, there's a few things I wanted to discuss, and maybe let's just start with the idea of intelligence. And so I have some disagreement with how people are defining intelligence as, and maybe I just want to go through that. So let me start with kind of how I define it, and then where I think some definitions could be lacking. And again, I don't pretend to know everything, and what I'm saying is correct, but it's what I believe is correct. Okay, so let's start with intelligence. And let me first demarcate intelligence into two categories. One I call potential intelligence and realized intelligence. And I'll define these in more detail. But essentially, potential intelligence is, and it'll make more sense, these definitions as I go deeper, but potential intelligence for me is if you did every test on something on an AI and every goal, and you perturbed it in any possible way you can, this would be the results of all the goals it achieved and the level of perturbations it did. And then observed intelligence or realized intelligence is an observed quantity. It's you actually ran a subset of these tests and you figured out that this thing is intelligent enough to write a book, and it had perturbations of you didn't give it enough information. So there's potential intelligence, which is like something can potentially be this, and then there's realized or observed intelligence. So let me just start with those definitions just to start. And so what I think intelligence is, and it's very closely aligned to some of Michael Levin's research in biology, but for me, intelligence is a degree of competency at navigating an abstract space. So the space isn't just three-dimensional space. It could be program space. It could be navigating the space of abstract programs. It could be navigating the space of poetry, semantic space. So I mean space in a more abstract way, depending. It could be the state space of a chessboard, right? These are all spaces. And its degree of competency, it can navigate this space. That's kind of the first part. And then it's toward desirable regions in the space. So towards a desirable goal. Like let's say as a chessboard, so a desirable space is you get checkmate on the opponent in this state space of pieces on the board. So that's the second piece. So navigating a space towards a desirable region in this space. And the third piece is by avoiding being trapped in local minimum. So if someone puts a difficult move in the way, you can overcome it, or if something unexpected happens in this space. So that's my definition of intelligent. So it's not philosophical. Like with this definition, you can't say, is Chris intelligent? Like there's no uncontextualized intelligence. So it's not philosophical, it's empirical, right? So you have to do a test, and the test is observer dependent. And so creating the test is also an IQ test on its own, right? Like a rat doesn't know how intelligent we are, right? Because he wouldn't know how to test us, right? He wouldn't know like, hey, are you smart enough to create an artificial general intelligence? And if we pass that test,
if we were to make it a little bit more tangible, like what do you think about the mechanisms we use to test intelligence, like standardized tests, for instance, and these things were also used to demonstrate the intelligence of GPT-4. Like, are those valid in this paradigm, or are they?
Yeah. So a good test needs to satisfy a few constraints. So it needs to be obviously measurable. You need to be able to prove it wrong or have a score on it. You need to say this test has been failed. The test needs to cover the goals that you want to achieve. And the test needs to be in such a way that if you change the test a lot, if you get the same outcome by changing the test a lot, then it was a bad test. So let's just take the SAT. So if you pass the SAT, what people may say, or if you pass the Turing test, which I think is a really bad test because it fails a lot of the things, and maybe I'll write some of these down and we'll release it in a blog post. But if you pass the SAT, you can't say this AI is intelligent. What you could say is this AI can pass the SAT test, and it did it in such a way that it didn't have a textbook, which it was just scanning. So that's a perturbation. So you removed all external databases, so it couldn't just do a lookup on how to solve some math. I only trained it on this. So if you added a bunch of barriers in the way, a bunch of potential local minimum, and it still passed the test, then you would just acknowledge which test it passed, and you said it's able to do that. And that would be its test of intelligence. And then if you were able, and so then my definition of artificial general intelligence is that it's able to pass every test with every single perturbation. And so then you would say, well, Brad, that's impossible. Like we would need infinite amount of time because there's an infinite amount of tests. Well, that's how I view AGI. Like everybody's always trying to make binary categories out of things. So to me, your level of generality in your intelligence is on a continuum. So if you've solved every single test, which is an infinite amount of them, with every single perturbation, then you're a pure artificial general intelligence in its purest form. If you solve 0 tests, then you're whatever the absence of any intelligence is. And then in the middle, you have the degree as to which you're in AGI. And so I don't think there's an AGI and not an AGI. It's just to what degree are you in AGI?
In that example, like, do we become the rats then? Because we can't really devise enough tests because we'd have to create infinite tests.
Exactly. And so I think eventually once AI becomes more intelligent than us, we will be able to stop knowing how intelligent it is, and we'll have to use AI to test AI and then trust that the AIs will need to design a test and tell us how intelligent the other AIs are.
Gotcha. I mean, it makes sense.
Yeah. So that's intelligence. So it's a very phenomenological, practical way. It's not philosophical. And I think it's important.
And so, I mean, in this paper, they did write like that it's a multifaceted and elusive concept. And, you know, I guess they say it's defined.
But I don't think it is.
Okay. So that's your argument, is that you sort of disagree with that premise, that like it's on a
continuum. Yeah, well, I don't think it's a
tangible
philosophical thing. Yeah. I think it needs to be scientific if we want to make progress. It needs to be a good explanation. And I think people need to research more about epistemology and just be very clear about how we obtain knowledge that something is intelligent or not. And so I see a lot of like philosophical things like, this is AGI. Like, when do we reach AGI? Well, it's when you have explored every test. And so potential intelligence is the result out of running every goal test with every perturbation. And so it's not observable. And then realized intelligence is what you've tested it on, then you know what what it's intelligent on those particular sets of tests.
And then you've reached
Cool.
that
So
general intelligence when you run out of tests.
exactly. And so it's a continuum. And so I talked on the last one with Christian about this difference between AI and AGI, and I was making a binary category just to simplify it, but I just wanted to add this kind of footnote to that. So I think with that, happy to jump in. There's some other stuff we can talk about of AI versus AGI, but maybe let's just jump in to the paper.
Yeah, sure. So like in the paper, their goal was to kind of run experiments or tests to some extent, but I think by the definition that you've given, maybe these are not the greatest tests, but nonetheless, they are interesting experiments and they go through different types of subject matter. I was thinking maybe we start with coding, partially because this is one where I think society in general and this paper, people see a lot of potential. It performs well on these tests. It's adaptable. It's able to consistently output workable code. And I think there's big implications for this in terms of like the job market and everything. But another element of it is like, is it also just super well positioned to learn how to code? Because code is text, code is well documented. It's something that, like we don't write down exactly why we made all the decisions if we're, for instance, writing a television program. The writers created, and it's a creative sort of abstract process. There's a lot of subjectivity to it and arbitrary decisions are made. But when you're creating code, it is a creative process, but in the end, you need to have a clear roadmap for how other people can leverage this, understand what it can do and how it works. And so my kind of question around this is like, do you think it's particularly well suited to become an exceptional that kind of renders the human element of it unnecessary? And also, where do you see that in relation to these other subjects, which we can get into, but where do you see that in relation to other things that are more abstract and subjective in terms of AI's adaptability to those tasks?
Good question, Chris. So as you know, I like to frame things as confluences of kind of what people think is orthogonal ideas. I call it a paradox or the barbell principle. And so this is kind of one of the fundamental premises of Super AI, the company I'm CEO of and that you work for. So in Super AI, we are different than other AI companies in that we believe in substrate independent intelligence. We don't believe that if you want to automate things, you should just use AI, you should just use humans, you should just use software. What we find, and we get amazing results with this, is that when you use humans and AI and software together, you get this kind of vector addition. So you have this like 1 + 1 = 4 or square root of 2 times. And I believe it's the same with coding. So if you just, especially today, maybe things will be different in the future, but especially today, I do believe it'll be valid for a very, very long time. Yeah, you can have the AI write some code. It's not going to be that great. I've been using it a lot. Or you can just have the human write code, but why not have the human and AI write code together? Because they're so orthogonal in their skill sets. And it's like, is the best chess player the AI chess player or human? No, the best chess player is AI and humans working together. That's the best chess player. And so what I've seen in my experiments is, and what I use it for, and it saves me an insane amount of time, is a lot of code is just boilerplate. There's just a lot of stuff that you have to write, and having the right data structures or debugging, or I need to write this unit test. Like there's just a lot of busy work in code. And what the what GPT does really well is just help you with this shitty work that you just have to do, and allows you to focus on the very deep creative work. And so that's how I view that.
Yeah.
What was your other question?
The part two of it was like, I see somehow that this technology is well suited to learn how to code because of the nature of its output. Its output as text, it's documented very well, whereas other things that are just less tangible, like, even if we look back to the paper, for instance, and this is a limitation of the model to some degree, but like for music, it just failed. It couldn't do anything. It could barely assemble like a chord structure. It couldn't change it. It was just like, it didn't get it at all. And like, maybe once we get this multimodal version and it can see images, it can start ingesting sheet music, and then this will be a completely moot point. But I do think that like the accessibility of the training data to the AI has a really heavy impact on its capabilities. And that's what leads me to believe that like coding is the most, I don't want to say threatened because that's subjective, but it's either the most threatened or it has the most potential, whichever way you want to look at it, to become kind of automated or really at least heavily altered by this artificial intelligence.
I agree. I don't know if there was a question there. I agree with you.
Really? Okay. So it's just a full agree on that one.
I can add comments. I don't know if there was something in particular, but I'll just kind of comment on some of the pieces. So yes, it's true. Why where we're at right now in talking about GPT, it's not like there was some huge algorithmic breakthrough. Yeah, we have transformers now that just make things really efficient and allow us to have a really long context window. But basically since even the 1950s of the perceptrons, it's basically the same algorithm, and we're still using backpropagate. Like it's a really old algorithm. It took a really long time to get here, but yeah, you're right. It's the data, and then it's just a massive amount of compute, and it just so happens that neural networks are able to ride the exponential wave and harness the compute and the data. And yeah, you're right. Like, what is the low-hanging fruit? Well, there just happens to be this thing called GitHub, and it's a place with a lot of code. And obviously, language is really nice in general because if I say this is sweet, right? So it's a symbol that we assign letters to, but it's an abstract symbol, and there's a lot swept under that symbol of sweet. Or if I say banana, like there's so much encoded in banana, like we take it for granted, but like when I say banana, like you think of this yellow thing, you think of how it tastes, you think of how it feels, you think of how it grows from a seed. Like you almost have the whole universe encoded in banana, because in order to have a banana, you need to have water. In order to have water, you need to have hydrogen. Hydrogen formed the beginning of the, so basically you have an infinite amount of information like encoded in a single symbol, which is not the case for images. Like in this pixel, there's not like an infinite amount of information encoded in this pixel. So language is nice in that it already operates at a high level of abstraction. So you already have almost basically these very advanced neural networks, aka our brains, that have encoded a vast amount of information in this vector embedding, in this symbolic vector embedding. And so you're already operating at a really high level of abstraction with text. And then it's just abundant online. It just so happened that all these things came about at a very similar time. Like if we would have had a bunch of compute, but not a lot of data, then this would be even delayed more. Or the same is true if we have a bunch of data, but not compute. But they just all arose at the same time. Like because we had better computers, then people all had phones and then took pictures and wrote things on Wikipedia. So it's definitely true. And then I think the other comment that like triggered me, what you were saying, is yeah, code is more than just code. Like I think when people think of code, they think of some coder, but like all web pages are code. Like a lot of art, especially in Figma now, if you consider that art, or Photoshop, like it's digital and it's code. And so automating code is actually probably automates a lot more than people think.
Yeah, definitely. And I mean, and then the counterpoint to that is that not everything that software engineers, for instance, do is just writing code. There's a lot more to it than that.
Yeah.
And so, maybe it's a different question whether or not AI will eventually be capable of doing these activities. It probably will, but it's certainly not the end all be all of what these roles are for people. One thing like kind of tangential to this is mathematics. This is an area where it doesn't perform that well. In this paper they talk about, I think it gets up to kind of like a high school level, it can do quite good. And then once you start getting into these more advanced concepts, things start to fall apart. It can't deliver proofs that are logical, and the floor kind of falls out from under it. I'm not a software expert or a math expert, but from my understanding, it's like, math is expressed with characters, right? And they're similarly meant to be these like logical proofs that you have to, write them out and prove that they're valid. So why does the AI struggle with this, but it seems to be more adept at ingesting code?
Yeah, it's a really good question. And I talked about this a bit also in the last podcast, but I think as we transcend this continuum from no intelligence to general intelligence, we're going to see the AI or AGI, whatever, act more and more human, and it'll be surprising because let's call it narrow AI. I'm going to put it in categories, but just remember it's a continuum. So we have the AI that can play chess, or we have the AI that can write Python code. And this AI is narrow AI because it's heavily constrained. So a really good AI is going to beat everybody at chess. But an AGI, when you ask it to play chess, is going to say, well, I don't know, I don't really want to play chess. I want to play checkers. And this AI is not going to make any mistakes. It's going to play a perfect game of chess, making zero mistakes. AGI is going to make a lot of mistakes. And the mistakes it's going to make are unbounded. And it's going to be creative and make mistakes and do a lot of things humans do. And so if you ask the same question about humans, which we can consider ourselves like pretty high up in the AGI scale so far, or maybe we're not, but as far as we know, I'll just say that probably we're like a measure zero set in the setup. But anyways, just to make it more practical. So I'd be like, Chris, how good are you at like Lebesgue integration? You'd probably be like, or I'm like, Chris, like, not to pick on you, but take Bob, multiply these 100-digit numbers. Like, and I'm like, I'm sorry, I can't do that. That's really difficult. Like, you could do it if I'm like, here, Bob, here's a piece of paper. Then you could do that because you know the algorithm. And so as AI gets more advanced, kind of the same thing's true of GPT-3. Like, it's good at basic math, just like Bob is good at basic math. It can handle certain word problems, but as it gets more abstract, it's not good at that. So that's one point. The other point is, the cool thing is this guy named Stephen Wolfram has been kind of like obscurely working away on this computational language called the Wolfram language. And what he's been trying to do is make everything computable. And so it's really a complement, just like we talked about the complement of human and AI, this kind of symbolic AI versus statistical AI that GPT-3 is very complementary, and they just integrated it into GPT. So now this is no longer valid with these plugins. Like, you can say, hey, GPT, like, do this insanely complex integral, and then it'll say using Wolfram plugin, and then it's going to do it, and it's going to be perfect. And this is why using kind of orthogonal vectors of tools is so powerful, because this is no longer a problem anymore. Like, check. Like, nothing's solved 100%, but the problem you just raised has been solved now.
Yeah. And I mean, they kind of, in a very simple way, they talk about this in the paper where they're asking GPT on its own, give me, like, I forget what they ask it to output it in, like some kind of code that they can visualize. Give me like a rendering of a screenshot from a game, and it has a river in the middle, and like to the side there's a city, and then on the left there's like some mountains. So they get it, they render it, and they show like what just GPT-4 can do. Then they go over to like Mid-Journey or one of these image generating ones, and they ask it the same thing, and then they get the output from that. And then they say, hey, GPT-4, give me an output, and then they pair it up with the image generator, and then they get a third one where these two work together. It does the image part, GPT does the coding part, and then the prompting part, I guess, and then you get an even better result. And I mean, this to me was kind of like, whoa, like this is going to change things big time.
And the other thing that makes me feel it's more human-like or higher in the AGI continuum is if you ask it to do some complex math, it makes a lot of mistakes, at least in the experiments I've ran. But if you say, and they call it chain of thought reasoning, if you say, hey, just speak out your reasoning, essentially giving it a scratch pad, does really well, kind of similar to a human. And so I also find that very interesting.
Why do you think that is? It's like thinking out loud, kind of.
Yeah, because what if you just kind of take a step back about what is GPT? Well, essentially, let's just say you were able to index all trillion tokens on the internet in like a database. Well, if you said, I don't know what the like first words of Mark Twain is, but like, or you just said like a long time ago it would probably like be very good at outputting in a galaxy far away, because the probability that given these tokens that the next token is in a galaxy far away is really high. And so the problem is like the space of all possible things you can say is just so big that you can't just have this lookup table, because you would need an infinite amount of data basically. And so what GPT has done, essentially compressed it massively, these trillion tokens, into a model of plus and of addition and multiplication. So it's a highly compressed model of language basically. And in order to have have that highly compressed, in order to predict what the word is, you have to understand a lot about the world. So you were saying, why is it that speaking it out loud helps it? So I think it's the same way that speaking or writing on a piece of paper helps humans. Is this is a highly compressed model, and it has limited memory, it has limited cognitive ability. And so if you don't have to solve it and this complex problem in one step, one forward pass through the neural network, like there's a bunch of studies that you like have this exponential increase in complexity as you try to solve tasks. And there's another way of doing it called semantic abstraction. So that's basically just breaking the task into smaller pieces. You need kind of an exponential smaller amount of data. Of course, you have to kind of have more, there's more complexity, and that you have to build each of these networks and stuff. But I think that's the reason.
I mean, it's like a pro tip for using these tools, really. Like, I just interact with it through the chat interface, but I find if you try to give it a prompt and then expect that it's going to spit out a perfect answer right after that, it's like, it's iffy. Some things it does all right, especially if it's like a short reply. But if you interject, or if you give it a series of different kind of criteria for what you want, you feed it information and you tell it how you want it to interact with the information, or you kind of stop it if you see it spitting out the output and it's like, I don't like this isn't what I want. You stop it and you say, hey buddy, consider this. It will perform a lot better. And I mean, this is probably going to be a big part of it too, is like learning how to use these things.
Well, a lot of people have asked me that and told me that. And that's why we built this into Super AI, is because there's so much kind of art to this, so much dark knowledge, as they say. Like, our team is reading papers on this all the time, running experiments. There's all these little tricks about like adding context, adding examples, and adding like this chain of thought reasoning. There's so many things. Like, we have this massive list of things, and then we have a massive database of prompts that work. And so that's one of the things we've done, is just make it easy for people. If you're not reading the research all the time, of course, if you are, go and do this on your own. But if you're not reading research hours and hours every day and testing this, there's a lot of these little tricks that make it work, kind of similar to a psychologist for AI. Like, there's a lot of tricks to get people to do, or performance coaches or whatever. We're like performance coaches for AI. And yeah, there's still a lot of art in getting what you want out of these.
Definitely. Cool. I'm not sure I have any further on this paper, unless there was like something else that stood out to you.
Well, maybe I'll just go through some of the highlights I saw. Like on page 45, they talk about using tools. And I don't know, I just felt that was like such a key moment, that like, wow, these AI can use tools. We talk about the Wolfram thing, but it's like, I bet if you looked at our history, like, and the continuum of AGI, like when we figured out how to use tools, like, that was a seminal moment in history, and now it can use calculators, and so I thought that was cool. Yeah, and then you talked about the software engineer, and then you said it was bad at math, but it solved the 2022 International Math Olympiad, and like, I used to compete in math competitions, and those are not easy to do. So I was really impressed about that. And then Fermi questions. So I studied physics, and they would always give us Fermi questions. How many atoms are there in the universe? How many, like the classic one is, how many piano tuners are in Chicago? Like, Enrique Fermi actually asked that one and did a really good job at these difficult Fermi questions. They had the personal assistant about like booking dinner. I can imagine very soon we'll all have personal assistants calling Comcast, which is like the worst thing to do in the history of everything. And then they had one about like fixing the leak in the bathroom. Like they just were like, help me solve this. And then it like figured out there was a leak of the bathroom. And then what was also interesting is it got into the theory of mind, about it was able to build up a mental model of what the other person was thinking. So like, what's actually true, was what I think you subjectively think is true, which any of us who has kids knows that it's like, holy shit, that's a big milestone. Like, kids aren't even able of doing that until a certain age. So that was interesting. And then it was able to resolve conflicts between couples, which was cool. And then like convince someone about vaccines. So I think there was other stuff about like creating propaganda and whatever, and some dangers, which I agree with. That's some of the stuff we talked about in the last episode. And they talked about giving it extrinsic motivation and agency, which actually scares me. Like, what I always liked about AI is that people always ask me like, is this thing going to want to kill other people? Well, like, what we're reproducing is not the entirety of the human condition. Like, we have many different elements inside of us. Like, we have a limbic system that tries to keep us alive. If someone tries to kill me, I'm going to try to not be killed. And I want to mate and eat and all these things, which is different than our neocortex, right? And so a lot of the AI is reproducing the neocortex. So there's no reason for for it to want to survive or mate or all these things that make us aggressive. But somehow I feel you could do that if you wanted to. It's not what we're doing now, but I feel like when you start baking these like limbic systems, then it makes it even more like humans. All of our aggression, that kind of scared me. I hope that doesn't happen too soon. Anyways, and then I think the really big limitation I saw, which they'll probably fix in GPT-5 or whatever, was it couldn't, I mean, I think it was on page 80. There was, so again, to take a step back, in an autoregressive model, so it just predicts the next word. It wasn't actually able to think to the end. If you ask it, how long will this prompt end up being? It gets the answer wrong because it doesn't know actually how long it's going to be.
I heard some people talking about that from like the user's perspective, where like, so if you use Bard, I haven't used it yet, but I just got access. I'm going to experiment with it. But if you use Bard and you ask it something, it spits out the answer like boom, all at once. But if you use Chat-GPT, it like comes out at you, and it's sort of like somebody's on the other side typing. And people were wondering like, is this to give people the like kind of this interactive illusion? But this makes me think, well, no, it's like it's thinking. I mean, kind of, right? Like,
do you think it's just kind of like actually a reflection of the corporations? Like, I mean, OpenAI is not as open as we hoped, but they're more open than Google. And so maybe they just release it as it comes out, whereas Google's like, let's make sure this thing's all finished and make it perfect and engineered, and it's going to be fast and like typical Google, and then we'll release it to you. I don't actually know. I haven't researched much about Bard, but I also just got access. I haven't used it yet.
Yeah, I mean, that's interesting. Like, even if you think about it that way, where it's like it gets the full answer first, and then they have an audit, an AI audit, and then you get something afterwards, instead of like you just get this stream of thought from the AI. I mean, no one knows, right?
Cool. Anything else, or should we wrap? I think that was an interesting line of questioning. Thanks for bringing it up. I know you wanted to talk about something else, but I think that was super interesting.
Good, man. We'll get to it next time, the previous topic, but I enjoyed this too. I mean, like I said, fascinating paper and like exciting, uncertain times, but exciting nonetheless. So like, let's keep exploring these topics and talking about them to the best of our ability.
All right, Chris, good stuff.